Thank you so much for joining in. The first thing we'll talk about in today's session is interoperability and sizing. Interoperability was missed out in our previous sessions. I would agree we could have started with that, but somehow that got missed. And then we will also talk about single site considerations. Let's get started. Interoperability and sizing. You may be wondering why interoperability is that important. Let me give you some details. Especially when it comes to VMware, you may agree with me that VMware only gives you the software component, right? The required software to run the solutions. Now, is it all enough to architect and run your applications? Not at all, right? You need to have hardware component to host those software applications. When it comes to NSXT, it is not playing a role directly with your hardware vendors like Cisco UCS, HP servers, Dell servers. Doesn't do a direct play. But the trick here is the hypervisor, the transport node, should be compatible with the hardware. The ESXi should be compatible, the KVM should be compatible. So that was about the hardware. Now think about the integrations with vCenter and also adding transport node, ESXi or KVM to the NSX manager. So you need to make sure that these systems are compatible with NSXT manager to run smoothly. It is all about how you want to take the risk, right? The interoperability is there for sure, and you want to make sure that your production setup is completely risk-free. Whenever there is a requirement from vendor to support you, they are able to support. Yeah, so this is all about it. Now, how do you make sure this can be verified and this interoperability details can be checked whenever you want to make any software changes, right? So this is what we are talking about. So if you carefully watch the screen, what I'm doing here is I selected NSXT data center version 3.0 and I'm checking the platform solutions, which is vSphere 7.0. yeah, and the result is if I go for 3.0, I need to have vSphere versions 7.0. This is how you can verify and confirm your NSXT version or whatever you're going for is supported. This is only one part of the discussion. You have other pieces also need to be verified, such as the KVM support and also the hardware support. Now for the KVM specifically, part of my blog post, you could see a URL where you can just open it up and you will see the list of supported KVM flavors. I highly recommend you to go through my blog for this. Now before moving to the sizing part, let's try to dig more into the hardware compatibility use cases. When you want to do a firmware changes in your network, whether you want to go for example HP server upgrade, software upgrade, right, or Dell software upgrade or UCS software upgrade, you need to make sure that whenever you make changes to those server software, it is also compatible with your ESXi, and the ESXi is compatible with the NSXT, right? This could be an ongoing process in your organization. Now let's talk about sizing, appliance sizing. We are mainly talking about NSXT manager appliance sizing. Now it depends on your NSXT manager versioning, the size requirement also changes. If you go for 3.0, you end up having 300 GB as a disk requirement, but if you go for 2.4, the requirement is only 200 GB. That is a difference. Now here is the thing, this all need to be part of your planning and design phase. Look, if you select a different size, based on the size, the NSXT manager role also changes. Now if you end up selecting extra small, it will give you cloud services manager, not NSXT. Now let's talk about small. Small is mainly for lab and POC. You will never go for small size in your production network. If you go for production network, it is not supported by VMware. Medium, it's a good options for a productions. Depends on your scale. If you see your environment can scale only up to 64 hypervisor in future, it is good to go with this medium deployment. If there is a chance to go for more than 64 hypervisors, you should select the size as large. So this is all about interoperability and sizing, a very small topic but very important. Alright, now let's move on to the next slide. This slide is super important and very interesting as well. Here we are talking about high availability, FT and compliance. All of them covering the single site design. Now you must have seen in my previous discussion, the NSXT manager comes with built-in high availability, clustering solutions, etc. But we cannot limit when we are talking about H and FT just to the NSXT manager level. We need to go beyond that. Let's start with the rack level redundancy. So the idea is you need to have at least two different rack unit. So when you are keeping your appliances, you are keeping it in two different rack. This is applicable for your core networking devices. This is also applicable for your access switch or Tor switch, and also for your transport node or your bare metal servers or the blade servers. Let's say you have 4 different servers. You need to make sure you are able to keep 2 of the servers in one of the rack and the remaining 2 in different rack. Now why rack level redundancy is super important? See, the first thing is, in case of a rack failure, your production operation should not be affected. Think about you are hosting all your core routers, Tor switches and the transport node servers in a same rack, and something happened to that rack. Yeah, so this is what we are trying to avoid. Now the topology in discussion here, it is for a small scale environment, right? You have only 2 rack unit and you want to make sure that the devices are hosted, the devices are distributed across the rack unit. So in case of one of the rack is not available, the devices in other rack will be able to continue the operations. Now the question is it all about rack or is it something to do with the power distribution? The answer is yes, it is mostly to do with the power distributions. Think about if your setup is having 2 power sources and all of the devices are getting power from 2 different power sources. In that case, chances of the devices going down because of single source failure is very minimal, right? If your environment is capable of getting power source from more than 2 distribution point, in that case it is ideal to have more than one rack, considering most of the devices will only have 2 power supplies to get power from. Now, do you really need to go for 2 different rack always? No, the answer is no. Think about you only have 2 power sources and the device can get power from these 2 power sources only. In that case, you can even stack all of your devices into a single rack, which is very much fine as well. So that was about the rack level redundancy. Then let's move on to vSphere HA part. If you look at this scenario 1, the scenario 1 is about a shared approach where your NSXT manager and the edge functions and workloads, the application workloads, are part of a shared cluster. You don't have a separate cluster for an application workload here. So this is a shared model and you have single vSphere HA cluster taking care of all your applications VMs, NSXT manager VMs, and the edge function VMs, etc. etc. When you are deploying NSXT manager on a vSphere cluster, you need to go for minimum 4 node. Why? In case of one of the NSXT manager fails, so these are the NSXT manager we have, NSXT manager 1, 2 and 3 here, right? So in case of any of these VM fails, it should be able to recover, the failed VM should be able to recover on this 4th node. That is why you need to go for minimum 4 node in a VMware HA cluster. Now let's also talk about our third point, which is use anti-affinity. The last things you want to make sure it is not going to happen is all these NSXT manager VMs are hosted on or happen to be on a single host. You need to make sure that the NSXT managers are distributed across the hosts. So this is why it is very important to use anti-affinity rules. So here you are saying NSXT manager 1 will be always on this host, right? And NSXT manager 2 will be on this host, right? And the third one is on host 3. So only when in case of the failure, it should go to the host 4. Otherwise, in usual scenarios, these NSXT managers will function from different hosts. So that is about the anti-affinity rules. Now let's get into the shared storage and subnet. Shared storage and subnet, it actually goes with the vSphere HA cluster concept. Why shared storage? It basically enables VMs to be restarted on a different machines in case of a failure. That's all about shared storage. Now about the subnets. The shared subnet is a requirement as well. When you move the VM, it definitely do a GARP to make sure that the ARP table is get refreshed. So when you do a GARP, the GARP is a broadcast process. So you already know that the broadcast cannot be span across different subnets. So in a sense, what it is telling, for vMotion kind of process, all of your NSXT manager should be part of the same subnet, otherwise it won't work. That's about shared storage and subnet. Now the last point which I want to touch upon when it comes to HA and FT is using dual NIC with dual homing. This is an interesting and debatable topic whenever we cross the boundaries of server team and network team. So let's talk about the dual NIC scenario. So in this topology, each of these hosts are connected to two different physical NIC. One of the physical PNIC, one of the PNIC is connecting to Tor switch 1 and the second PNIC is connecting to Tor switch 2 from each of the hosts. So this makes sure that in case of any issue with your physical NIC or to the upstream switch, the traffic is able to fail over to the second physical NIC. That way it can use the second upstream switch to connect to or talk to any other servers. Now the interesting debatable topic, dual homing, right? So what dual homing means, this host 1 is connected to two different Tor switches, which is actually the dual homing part of it, right? The host is dual homed to two different Tor switches. If it happens to be a Cisco switch, we are talking about VPC, right? So we are making sure that these two interfaces, PNIC 1 and 2, are teamed to the both Tor switches. So on the Nexus switches, this will be called as VPC. If it is an Arista switch, they do MLAG. Now why some of our good old VMware folks are against this idea? It is this part, right? Whenever there is a traffic going out of host 1 to Tor switch with MLAG or VPC, it is going to two different switches, which in turn creates complexity especially if you want to track the traffic. Half of the traffic will be going to one of the switch and half of the traffic could be going to a different switch. Depends on your load balancing hashing mechanism. So this introduced some friction between the network engineers and the server engineers. So this is all about it, right? The troubleshooting complexity. Other than that, from the design perspective, this is actually making sense to use two different switches because we are getting extra switch level redundancy. Especially think about you're connecting both of this PNIC to a same switch and that switch is not available, right? Your complete host is isolated. So from the design point of view, it is always better to go for a dual homing. But when it comes to troubleshooting, it depends how comfortable you are with the technology. Sometimes your troubleshooting will get messy as well. Before moving to the scenario 2, we will also talk about compliance. So when it comes to compliance, it is all about how you want to segregate your traffic. In most of the organizations, there will be some policy to segregate the server traffic, the management traffic, etc. Right? So here, the discussion is how you can make sure your management traffic is isolated from your data traffic. So there are different options when it comes to NSXT. One of the thing is use separate PNIC, physical NIC for management and use separate PNIC for data traffic. If you look at the shared model which we discussed or these topologies, we are having only two PNIC and these two PNIC carries the management and data traffic. Let's say if you have an option of going with the 4 NIC on a host, then you can consider having a separate PNIC for management. Two of them you can assign to management and the remaining two you can assign to data. Or you have a server build, let's say it comes with two 1 gig link and two 10 gig. Probably you can use that two 1 gig link for management, carrying management traffic and remaining two 10 gig for data traffic, right? So this ensures that the compliance is taken care. Now if you want to take your compliance requirement to a next level, you can have separate DVS for your management PNIC and a separate DVS for your data PNICs. So let's say you have two PNIC and these two PNICs connected to one of the DVS and you have another two PNIC which is on the same server, then that PNIC can be connected to a different DVS. You can also have a DVS, dedicated DVS for carrying management traffic, meaning the management traffic physical NIC will be hosted on or connected to a separate DVS and your data traffic is hosted on or data traffic PNICs are part of a separate DVS, right? This is another options you can go. Now you go for DVS or NVDS, that depends on your NSXT manager versions and your environment as well. If you're talking about 3.0 with vSphere 7.0, you can directly go for DVS. If you're talking about NSXT 2.4, then you can only go for NVDS. And there is an interesting discussion here as well, that is about VSS. It is about the standard switches. In very conservative environment, you will see the management traffic is hosted on a separate VSS standard switch and your workloads are part of a separate DVS. Is it going to work? It is for sure it is going to work, but you are missing out some of the cool use cases which is part of DVS. Look, with VSS it is a standalone switch for each of the hosts, right? But when it comes to DVS, it gives you a distributed switch. You can attach multiple hosts as part of that distributed switch. That is a key thing. So that is the difference there. But if your compliance requirement insists and you want to be super conservative, you can even go for that option. Lastly, let's talk about scenario 2. The scenario 2 is kind of a compliance discussion again, right? Your workload cluster, which is your application cluster, should be completely separated out and should be owned by the application team. And for all your management purpose like NSX Manager, vCenter Server, or Edge functions, VRNI, all of those management elements are having a separate cluster. Here example, there is a NSX Manager, right? There is an Edge functions, there is a vCenter server, right? All of them are part of a separate cluster. So this is a better design for sure, especially if you want to separate your workloads from your management. Your platform team will be administrating this collapsed NSX management and Edge cluster, and your applications team will have their own cluster environment, their own physical servers. From administrative domain perspective, this works beautifully well, but the resource requirement is more here. You will end up having 6 servers versus the 4 server requirement we had in our previous case, which was with the shared cluster model. And for sure, your rack level redundancy, your anti-affinity rules, shared storage, subnet, all of those elements should be taken care here as well. Finally, I want to also make sure you understand this part, which is the VXLAN. So I mentioned here VXLAN, so you will see VXLAN here and VXLAN here. Why VXLAN? Let's understand it here. With VXLAN, it allows you to extend L2 network across bare metal hosts, racks, even across the site, all without extending spanning tree. That means you will not have an L2 loop with a spanning tree. Isn't it cool? And this is exactly offered by physical networking solution vendors such as Cisco and Arista with their ACI solutions or CloudVision software. So I encourage you to make use of this for your physical networking. Let's debate and address some of the argument here. The first thing is running Geneve over VXLAN, encapsulation over encapsulation. Is it really a trouble? We are talking about modern networking with a 10 gig, 40 gig, 100 gig, sometimes 400 gig bandwidth. And the second thing is about MTU. The MTU should be 1700 or 9000. If any of the vendors not supporting this MTU, they should be out of the business. So I really encourage you to consider running overlay based solution for your physical network. So this is all I have part of this sessions. Hope you enjoyed. We will have next session covering multi-site scenarios. Thank you so much for watching. Happy learning.